Hey chemists, I'm getting you set up on your lab here for today. What I'm starting with is the lab that will be a pressure-temperature relationships lab, and for this lab you're going to need these two items, or one of these items. There's three of them, so we can have three groups. And what you've got is a silver ball here that's got air in it, and at the top you've got a pressure gauge. And one of the things you'll notice about the pressure gauge here is that it's reading about 15, and in fact each one of those pressure units is a half. So right now, if I were reading this pressure gauge, I would call it about 14.7 or 14.8. And if I'd read this pressure gauge, those are even smaller units, but each of those large lines between the 10 and the 15 is 1. So here you get even a little better precision. So maybe you'd call that one like 14.8. And on this one, if this is the one you use, this one's back to that. Each little line is worth a half, so I might call that 15.7 or 8 or something like that, because it's there between the 15.5 and the 16. So that's how you read your pressure. Now what you're going to do is super easy on these labs. You're going to take one of these pressure gauges and you're going to go to each of these cans. You'll see there's a set of cans there. This one is going to be the hottest water, so it's going to be all the way turned up. And this one's going to be medium water, and it's going to be turned up about halfway. And you notice there's thermometers in them. This one's room temperature. It's just sitting here hanging out for you. It's room temperature. We're going to come to this side, and now what you're going to see on this side in this position is going to be this can right here, and it's going to have cold water, and I'm going to put fresh tap water in there. And then this can's eventually going to have acetone, which is that, and dry ice in it, meaning it's going to be super duper cold, but I got to get you the dry ice first. So this is not one you're going to do in class unless you're in 7th hour. If you're a 1st hour person, you'll need to come back in seminar when the dry ice is here and run this thing during seminar. And it'll take about 2 minutes, so it shouldn't be a real big time commitment for you. So anyway, that's going to be tap water. That's going to end up being dry ice, and it's going to be sitting here on the corner. Then our other two, which are also going to be over here, this one's going to have some ice cubes in it, and it'll sit about right there. And it's going to be cold, but it's not going to be super cold, yet it will be colder than the tap water. And then this bad boy here is going to have a lot of ice in it, and so therefore it should be pretty close to 0 degrees Celsius. Now at any one of these stations, here's what this looks like. Easy data collection. You're going to say, okay, great, I've got a cup full of water, I'm going to put my sensor in there, and I want to make sure it's fully submerged. So now it's all the way in, and the pressure is going to change, or I think it should change in most cases, once you have your bulb immersed. And you're going to read two things. One, you're going to read the pressure there to the nearest 10th of a psi, so 15.4 or something. It looks like it's gone down, so that's 15.4. And then you're also going to say, okay, well, great, and you've got 2 people in your group, and I just am myself here tonight, so I'm just going to set that up against there. So the other thing you're going to read is the temperature, and I'm going to just take this bulb out of here for safety's sake. And you're going to read your temperature on these old-fashioned thermometers, and the temperature on this one, I don't know if you can see that or not, but there we are, a little bit better focused. Maybe not, it's pretty terrible actually. That's going to be right around 21 degrees Celsius, and that you can again go to the nearest 10th. So find your pressure and your temperature values both to the nearest 10th of their respective units. So thermometer can stay in, it will stay with any given can. Then you'll go from the one station to the next. So if I was on the really cold one, I can dry off my bulb, and now I'm going to go here to the pretty cold one. And then I'm going to go to the next one, and I would probably be honest and tell you, do not do the acetone in the middle somewhere, and for sure don't go from the hottest one to the coldest one. So don't go from that one over there, which is going to be at a rolling boil probably, to this one right here, which is going to be the coldest, or vice versa, because it'll not be very good for the pressure sensor or the pressure gauge. So you're going to go to those 6 or 7 stations, and at each one of the stations, all you're doing is recording, boom, a pressure value here, and ta-da, a temperature on the water in the can. I'm guessing the spread of temperatures by the time we've collected all of our data. I think the one with acetone in it's going to be in the negative 50 degree range. I could fully believe that the one over here with the hot water in it's going to be 80 or 90 degrees Celsius. So I think we'll have a pretty strong range of temperatures. This one's hopefully going to be 50 or 60. Room temperature right now, as I'm looking at it, room temperature, this has been sitting in here all weekend. We are at just under 20 degrees Celsius in that one. The one that comes straight out of the tap should be a little colder. Your small amount of ice should be a little bit colder, probably in the 10-degree range. That one ought to be pretty close to 0, like 2, 3, 4, and then we're going to blow the roof off going down on that one. So that's the data to collect there. It shouldn't take a real long time and is pretty safe and straightforward. I'd prefer you to wear goggles. I don't think you need to wear an apron on that part of the lab. So collect your data there. We're good on that, and then we'll finish up processing the data on that starting in class tomorrow. The other lab that is happening at exactly the same time, so some groups will be working on this lab instead, involves this whole contraption here. So you've got, and I'm going to set this up so you can see what I'm working with. See if it'll flip over for me. There we go. You've got a LabQuest, and hooked up to the LabQuest there is a pressure sensor. And you can see that pressure sensor right here. And the pressure sensor should be set on the syringe. The front tip of the syringe is at 10, which is right here. You're always going to measure to that point on your syringe. Okay. So now in terms of how we collect data, I'm going to change the settings here. And you'll notice here it says time-based. We do not want time-based. Instead of having time-based, you're going to want to click on that screen and change it from time-based to events with entry. And I'm going to hit OK. And there we go. Okay, so now what'll happen? It looks like this. It's this easy to collect your data. I'm going to hit down here in the bottom corner. I'm going to hit play. Okay, now it's ready for me to collect data, and you see a little red dot, and when I push the plunger in, the red dot goes up. If I pull the plunger out, the red dot goes down. Okay, so I'm going to push that plunger in all the way to 5, and I'm going to hold it steady. And so right now I'm at 5. Now I'm going to put my phone down so I can hit the keep button. Right there in the bottom left-hand corner, there's the keep button. So I'm going to hit that keep button, and then I'm going to pick my phone back up. All right, there's what it looks like after I hit keep. Now, I can let go of the pressure sensor, but I'm not going to. I'm going to set the phone down again. What I need to plug in for keep here is my event was 5. So I'm going to plug in a 5 because this happened at 5 milliliters. And now on the screen, you see one red dot that's been saved. Okay, so then I back it out, and our next data point happens at 7.5. And you'll see here where I'm at 7.5, the front ring of the piston is in between the 7, which is right there, and the 8, which is right there. I just want to go slide right into that 7.5 mark, and got it. And it's easier with 2 people. But now I'm at 7.5. I'm going to go ahead and hit keep again. And I'm going to type in. There's my screen. I'm going to type in 7. Oops, that's a cancel. There you go. Delete that. 0.5. And I'm going to hit OK. And now on the screen, I have 2 data points. All right, we're going to go again. I'm going to take this back to 10. And at 10, it should be its normal resting position. So now I'm at 10. I'm going to hit keep. And this is an event that is a 10, so I'm going to hit a 1, and then a 0. Got it. And I got 3 data points. And you're going to keep going backwards every 2.5 milliliters. So you're going to have a data point at 12.5. You're going to have a data point at 15. Now I'm really having to put some pressure on it. Now I got a data point at, 17.5. And then my last data point happens at 20. So you're going to collect data points at all of those locations. And then when you're done collecting your data, and again, it shouldn't be a real long data collection, all you got to do is hit this stop button. And yes, you can I'm going to hit cancel here. I think I hit that too many times. So I get the stop button hit. Boom. Okay, that's what it's going to look like. Now, on your screen, if you didn't get a chance to record your data, what you'll notice here is it's going to tell you the pressure and at what time that happens. So you can click on that next data point there, and it tells you the pressure and at what time that happened or what volume that happened. I do the same thing there. Boom, there's my pressure and there's my milliliters. And now I can record that information and off we go. The only other thing that I want you to do here is I want you to go to the graph menu, the analyze menu. And then down here it says curve fit. So So we're going to do curve fit, and we're going to curve fit pressure. Now, this kind of plays in nicely with what we've been doing in Algebra 2, because the kind of curve fit we're going to choose, we are going to choose a power. And so your Algebra 2 lesson is going to smell a little bit like this here today. We're going to take this power graph, and it's going to give us an equation with an A, B, and then we've got that little X there. And if you do me a favor, just write that down somewhere by your data table would be fine. That'll be something we can use for comparison purposes in the future. And yours, I think, is going to turn out nicer than mine does, because I only have 3 data points, and that's kind of weird to only have 3 data points. But it will be good for us to at least get this before we do our calculations in Google. There's a lot of different other choices you could choose here, but really the power model is the best one for the data set that we have. Then all you got to do is hit OK, and ta-da, the line is on the graph. That's fine. And if this is what the screen looks like when you walk up to it, all you have to do to be ready to collect data is just hit this play button, and it's going to say, do you wish to overwrite the data? And yeah, okay, that's fine. And you can hit discard, and now it's ready to collect data for the next person. So if you get to there and it's got something on the screen, just hit the play button, discard the data, and off you go. All right, so 2 chemistry labs, that's how they roll. Pretty easy data collection. We've got the one over there, which is pressure and temperature. We've got the one here with the gas pressure sensor, that's pressure and volume. Both of these labs, I think you can get data collected on in the time remaining today. All right, tomorrow we'll talk about what to do with the data and get Chromebooks and do some serious graphing work. Thanks, Wildcats. Have a great day.